Complete case analysis and simple imputation are perhaps the most common ways to account for missing values in a dataset. Here we want to introduce multiple imputation and show how it can be built into your data analysis workflow. Machine learning algorithms implemented in scikit-learn and other similar libraries assume that all values are filled in and that they hold meaning. Another reason to consider imputation is that the data is precious. It could be precious either in terms of the training data itself or in terms of the cost to obtain it. Either way, if we can use the incomplete data, we should. A common approach, such as using the mean of a given feature, is an example of a univariate imputation. Also, because imputation was carried out only once, it is a simple imputation. Multivariate imputations use additional features, and multiple imputations iterate over several possible imputation scenarios. The practice of imputing missing values introduces uncertainty into the results of a data science project. One way to deal with that additional uncertainty is to try a range of different values for imputation and measure how the results vary between the different data sets. Scikit-learn has an iterative imputer tool for modeling missing values. It can be called repeatedly to generate a number of different data sets with varying imputed values. Then, later in your data science workflow, after settling on a particular modeling pipeline, you would use these different data sets as inputs and evaluate how the outputs from your pipeline differ depending on the missing value imputations used. This tool is based on the well-known package mice from R. While it may be beneficial to try the iterative imputer tool when working with a dataset with a lot of interrelated missing values across several features, it is important that you know how to build your own multivariate imputer. Then it is just a matter of using function calls to create multiple imputed datasets. Recall the avail data that were compiled during data ingestion. In this example, we will impute missing values from the isSubscriber column. Here we use one-hot encoding to expand the country and subscriber type columns. We also include the other features that might be useful for imputing missing values. This is an educational exercise, and for this reason we are showing you how to add missing values to these data. Adding missing values to a dataset to better understand the effects of imputation methods is a useful tool. Think of this example and code as a sandbox or as a template for other datasets when exploring new imputation methods. In order for this to work, there needs to be a relationship between the features. We can plot the pairwise correlations as a grid to better understand whether or not this is a reasonable assumption. Remember that before we view a plot, we should think about what we expect to see. It's a habit for quality assurance. Before we visualized this plot, we expected that subscribers from Singapore would be negatively correlated with being a subscriber. Here we use logistic regression to impute the missing values in column 1. The other columns are used as predictors. The parameter C is the inverse of the regularization strength, and it must be a positive float. Like in support vector machines, smaller values specify stronger regularization. The F1 scores are something that we could improve on, but with real data, you wouldn't even know this, unless you performed an experiment like this one. Feel free to use another model in place of logistic regression to see if you can improve on the predictive performance. The important thing here is that there is a regularization parameter that we can change to allow for multiple imputations. Here we have generated the new datasets. Some number between 3 and 10 versions is usually sufficient to ensure that you have an understanding of the variability associated with your imputation strategy. By removing data and carrying out imputation, you now have an additional tool to compare strategies without proceeding all the way through the workflow.